Welcome to this video on clustering techniques. Today we are going to understand k-means clustering. Let's dive in. So, what exactly is clustering? Clustering is an unsupervised machine learning technique. It groups similar data points together based on their characteristics or features. These groups are called clusters. A few key points to remember are: data points within a cluster are more similar to each other than to points in other clusters. No predefined labels or categories are needed. Clustering helps discover hidden patterns and structures in data. Let's break down the steps involved in the k-means algorithm. First, choose the number of clusters, which we represent with the letter k. Then, randomly initialize k centroids. After that, assign each data point to the nearest centroid. Next, update the centroids based on the assigned points. Finally, repeat the assignment and update steps until the algorithm converges, meaning the cluster assignments no longer change significantly. Here is an example of how to implement k-means in Python using the NumPy library. First, import the NumPy library as NP. Define a function called k-means, which takes the data x and the number of clusters k as input. Randomly initialize centroids by selecting k data points from x. Iterate up to a maximum number of iterations. Assign points to clusters by calculating distances to centroids and choosing the closest one. Update centroids by computing the mean of points in each cluster. Let's explore the mathematical foundation of k-means. The k-means algorithm aims to minimize the objective function j, which is the sum of squared distances between data points and their assigned cluster centroids. The objective function is represented by the formula j equals the sum from I equals 1 to k of the sum of x in c subscript I of the square of the norm of x minus mu subscript I. In this formula, j represents the objective function we want to minimize, k is the number of clusters, c subscript I is the set of points in cluster I, mu subscript I is the centroid of cluster I, and x is a data point. The algorithm minimizes this function by updating cluster assignments and recalculating centroid positions until convergence or the maximum number of iterations is reached. Determining the optimal number of clusters k is crucial for effective clustering. Here are some common methods to help you choose the right k value. The elbow method involves plotting inertia, which is the sum of squared distances, versus k. Look for the elbow point in the plot, where the rate of decrease in inertia starts to slow down. Silhouette analysis measures cohesion and separation of clusters to help determine the best k. The gap statistic compares the clustering performance with that of a uniform distribution. Finally, consider using your domain knowledge and business context to inform your choice of k. Let's explore the advantages and applications of k-means clustering. K-means offers several benefits, including simplicity and ease of implementation, scalability to large datasets, guaranteed convergence, and compatibility with different data types. However, it also has limitations, such as the need for a predefined k value, sensitivity to outliers, the possibility of converging to local optima, and the assumption of spherical clusters. K-means is commonly used in various applications, including customer segmentation, market analysis, image compression, anomaly detection, and document classification. Let's walk through an implementation example using Python's scikit-learn library. First, import the necessary libraries: NumPy for numerical operations, k-means from scikit-learn for clustering, and matplotlib for plotting. Generate some sample data using NumPy. Create a k-means model with the desired number of clusters, for example 3, and fit it to the data. Get the cluster assignments, also known as labels, and the cluster centers. Finally, plot the results using matplotlib, showing data points colored by cluster and centroids marked with red X's. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.